right, good afternoon, folks. Thank you very much for joining. My name is Gil Haberman. I'm from Riverbed. Today I'm going to tell you a little bit about how we can help with cutting business costs and risk associated with disaster recovery, and in general, kind of operationalizing both branch offices and the applications that you have on EC2. So I'll cover a few kind of key benefits that we drive with a couple of products. One is called SteelHead. I'll tell you a little bit about how you can optimize application and replication performance across sites with that product, and then talk to you a little bit about how you can centralize and simplify backup operations, data protection with SteelFusion, our converged infrastructure solution, and then tell you how you can very easily achieve instant branch recovery as well as disaster avoidance with this solution. So what I'll do is jump between kind of telling you about how cool technology, what kind of cool technology we provide, explain how the technology works, so it's kind of fun for the techies among you, and then also in most sections talk about the key value drivers and kind of benefits that this solution provides. Okay, so this was 10 years ago, maybe 15 years ago. It was a very simple life back then. You probably remember we were all like farmers, living simple lives. There was kind of one MPLS connection usually between sites and between data centers and branch offices. And we thought that was really cool, but relative to now, it seems like peanuts, right? Today we have the ability to serve and the need to serve so many more mobile applications, mobile users with multiple devices. And we serve applications from a wide variety of sources: AWS, SaaS applications, data centers, and of course, branch offices. And so the level of complexity has really risen, and it's because of really cool innovation, but it also means that it gets increasingly challenging to understand what are different SLAs we have across different types of networks, so connectivity challenges. And in terms of performance of applications, it becomes increasingly challenging to understand and gain visibility into what's happening, where data resides, what's holding networks in case of slowdown. And of course, recovering from disasters is challenging as well because we have data across different sites. And so what I'll share with you is some of the solutions that we provide in order to accommodate for the different challenges. So to those of you who are not familiar, we're the leader in delivering WAN optimization solutions. And WAN optimization is, I think, a really, really cool solution to the techies among us. And it really is a technology that aims to provide and streamline application delivery across sites. It's a symmetrical solution. So when I talk about SteelHead, our product, I always refer to having a SteelHead appliance, or either physical or virtual appliance, on both where we send information from and to, right? So it's a symmetrical solution, and it uses a combination of technologies to massively reduce the amount of bandwidth that is required to support applications that are delivered across the wire. So the first thing that we do with data streamlining is really deduping as much as we can. We basically look at the data, divide into small little chunks. First time you send it over, we mark those chunks of data, and then later on, as data that can be deduped is sent over the wire again, we only send the references, not the actual data. So what this means is, imagine, on Outlook, people sending back and forth emails with an attachment. The attachment is basically either the same or the same with slight modification. Since we look into the data, breaking down the data, in this particular case, we can basically dedupe almost 100%, right? It's always kind of the same file moving, or 99% same files moving across the wire, and so we can save bandwidth significantly that way. Now, on the networking layer, what we do from a transport streamlining is really help streamline TCP. So TCP allows for multiple packets to be sent without acknowledgement, but with time, that window fills up pretty quickly due to latency. And so what ends up happening is that bottleneck is what determines the performance of applications across the wire. What we basically do is accommodate for some of these local acknowledgments locally, either where we intercept the data, so where you send it, or coming back. And so we effectively answer most of the acknowledgments on a LAN-like speed, resulting in improving the effective ability to streamline data in orders of magnitude. And so similarly, what we also do on an application level is look into the application, be aware of what's happening with protocols associated with specific applications, and again, reduce the level of chattiness. So imagine an application protocol is asking for several reads in a file, read, acknowledge, read, acknowledge. What we do, since we are aware of that, is basically get all the reads locally on LAN-like speed and only then send stuff across the wire. So you can see that since everything is supporting one another and each can help orders of magnitude in terms of reducing the amount of bandwidth needed and associated latency, we can have a very high impact on the overall amount of data that we can send. And so you can see performance gains of even 100x relative to having no WAN optimization solution. Now, one thing that we've done in the past 2 years is really expand the number of solutions that we provide for different locations, and one of which is, of course, having SteelHead for EC2. And the idea here is that you basically spin up this virtual appliance at EC2, supporting the appliance that you have in the destination. But the difference is here, you do this very, very easily from a specific console that we provide with kind of bring your own licensing. So you can do that on a subscription-based licensing and scale those appliances with time as you need. And so similarly, we provide this type of a solution for all these types of different topologies. So it's for your own to the data center, for the branch office, for EC2, and also working with vendors for different solutions with SaaS providers. And then finally, for mobile apps that you provide to mobile devices. OK, so now let's talk a little bit about how we can help with backup, and in general, kind of helping operationalize some of the challenges that you have in branch offices and remote locations. So in general, what we're seeing in the market is that we spend a lot of time thinking about remote locations, and we don't see them going away anytime soon. The reason is organizations have been continuously trying to centralize operations as much as possible, but many, many times we see that you still have to have some applications that reside close to users. Maybe they're very intensive in terms of read and writes, working on graphics, or they write to a local database. In any case, they cannot be centralized. And what ends up happening is that we have many locations. They're each very, very small, but they're still out there. And so a lot of what we do is try to think about how we can help. And the primary driver for kind of inefficiencies out there is data. You can see here that over 50% of companies in this survey report that over half the data that they have is still out there in those custom or write-intensive applications. So despite efforts to centralize applications, we still have a lot of data out there to protect. And so what ends up happening is that, although it's not a lot of infrastructure, from a business continuity and disaster recovery perspective, these are really hard to handle. Also, in parallel, we're seeing that more and more applications are considered mission and business critical by users and organizations. So not only the amount of data keeps on growing, but also the number of workloads and the data associated with them that you need to protect keeps growing and increasing in size. So overall, what we're seeing is that these remote locations are very hard to support because we don't have local IT staff, and they're very cost inefficient, right? It's very hard to drive high levels of utilization out there when you have a bunch of small little islands, up to 50 times the number of these small islands relative to the number of data centers. And at the end of the day, since we don't have local IT staff, the data is generally at risk. What ends up happening is that a lot of the data protection practices, for example, we find, are actually operated by local folks that are not really trained for that. And so generally speaking, these locations are a lot more subject to downtime because of kind of the lack of strong IT support and operational efficiency. So our solution is basically a converged infrastructure appliance that is designed specifically for these challenges in these branch offices or remote locations. Now, when I say converged infrastructure, I basically refer to some kind of a pre-integrated or pre-configured appliance that includes compute, storage, networking, and virtualization bundled into one. Now, most of the time, you probably heard about these solutions in the context of data centers. And the idea is to have some kind of workload-optimized solution that you can easily scale. And a lot of customers like to deploy these solutions because it's very easy to deploy and then scale as you grow. Now, what we've designed is really an appliance that is specifically targeting the needs that I talked about. So it's also an all-in-one brand platform, but the idea is to provide a lot of cool things associated with it. So it comes with VSP, which is our flavor of vSphere, so you can control and provision virtual machines remotely. And it also includes what we call Blockstream, which is a really cool technology. What it basically allows you to do is centralize all the data to the data center, yet operate locally. So what we basically allow to do is to take a LUN from the data center, or an EC2 instance, as we are going to talk about down the road, and basically project that to that remote appliance. So the data now resides locally and you work locally, but after writing to virtual machines, we basically sync the data back to the data center. So the outcome is that you have centralized data that is up to date, which is very, very useful for data protection and replication, right? But from a performance perspective, you perform and you run workloads locally out in those remote locations. And then finally, it comes with SteelHead, the WAN optimization solutions that I talked about before, that really is about trying to optimize the traffic for the applications that you were able to centralize, to optimize the application delivery of applications that reside in the data center. So this is how a topology would generally look like. We have the converged appliance out in the branch that includes everything I talked about, and it really consolidates all the remote IT out there, but also provide local performance. And then we have what we call SteelFusion Core, which is basically a controller that interfaces with the local storage in the data center in order to do that projection that I talked about. So projecting a subset of the data out of the data center, and then making sure that all the data is synced back to the data center as you read and write accordingly in these remote sites. So we have one of these controllers, SteelFusion Core, supporting multiple branch offices and remote locations. The important thing that I want to emphasize is basically we do not replace storage in that data center in this example. We simply interface with it in order to project out those subsets of data that we call working sets to these remote locations. And so what we've done, working with Amazon, is taking the AWS Storage Gateway to deploy that in the data center and allow to effectively and seamlessly integrate the storage in the data center to EC2. And so the idea now is, if earlier I talked about centralizing storage, this would allow you, this topology would allow you to effectively move to a model where you use the storage gateway to centralize to Amazon EC2. So although you're running here locally at the branch, the data is synced here and then here to centralize all the data to one place, in this case, Amazon. Again, you can do a combination of either centralizing just to the data center and/or centralizing some of the data to Amazon, but the key concept here is that you have everything up to date, centralized out of reach of each separate site. You can read more if you want about this white paper at Splash, our content portal, if you want to read the specifics about how to deploy this type of topology. OK, so one of the benefits associated with this topology in general is that you vastly reduce the overall branch footprint, the physical footprint out in these remote locations. You replace all the infrastructure with just one box that converges all the infrastructure. And then more importantly, from an operational perspective, you never have to get out to any of these branch offices or remote locations ever again. Even the initial provisioning, you can send out an appliance out there, and the provisioning is done through vCenter and Blockstream, our storage delivery technology. So you basically provision remotely, and then you maintain all the VMs, again, from the data center. So you basically eliminate the need to ever fly and fix for any reasons, whether this is a software issue or a hardware maintenance of some sort. OK, so now let's think about it from a BCDR perspective. So if we look at kind of a typical provisioning and protection lifecycle of a branch office or remote location, and honestly, any type of site, we basically have some kind of time associated with provisioning that site. Then the site is up, and we keep on protecting data out there, usually some kind of an RPO window of maybe 24 hours, maybe protecting daily. So the recovery point objective, or the amount of data we might be putting at risk, is 24 hours. And then when something does happen locally, from a recovery time objective, it takes maybe a number of days to recover in case of a disaster or an outage locally. So what I'll do is kind of guide you through how this solution can help in all these three elements and see where we reach at the end. So first of all, when we think about data protection, since we've centralized data, we have essentially eliminated the need to protect the data in each of these remote sites. So that saves a lot of money, but also really helps organizations who have many remote sites that have challenges protecting each of them locally. So effectively, what ends up happening is you have all the data centralized and up to date in the data center or at EC2. So now you can effectively use the enterprise data protection practices to protect all the data at once. So you can use snapshots, array-based replication, everything you have in the data center that is more advanced and is more rigorously evaluated every so often in order to make sure that data is indeed protected in that site. Now, the other piece is what's happening here, and you've probably seen this with tools like Site Recovery Manager from VMware and other kind of virtualized tools in the data center. You basically are able to very easily avoid disasters. So when I talk about disaster avoidance, the idea is a hurricane is coming, an outage is very likely to occur, and what you decide to do is preemptively move services to another site. It can be across zones with Amazon, or it can be across different locations, across data centers in your own environment, right? Now, this is very hard to do in physical and, of course, in general with branch offices. But with this type of technology, it makes the disaster avoidance process really, really easy. Effectively, since we have an ability to sync the data and centralize it, we can simply shut down the VMs at the site that is at risk, the branch office, the remote location, whatever that may be. The data is automatically synced back to the data center, and now we can turn on these virtual machines, these services, either in the data center or project them out to a different branch location, and we do so in an application-consistent manner. So there's no corruption, there's no data loss. It's very, very easy to do, and once the danger of outage has gone away, we can do the same to move the services back to that branch location. Now, when there is actually a disaster out there in the remote location, we can do a couple of things. One is, since we have the data centralized, we can bring up immediately these virtual machines and serve users from the data center. In this particular case, we recover basically immediately, but virtual machines are now served from a remote location to these remote users, so performance might be degraded. But in any case, we've done that immediately. The other option would be to project those data sets onto a different SteelFusion Edge appliance in another remote location. In that case, again, we recover within minutes, and we can serve users from that other branch that is closer to the users. So in any event, it only takes a few minutes to do this recovery process, which is a massive, massive improvement relative to what usually happens in these remote locations, where recovery, we know empirically, takes days. In this particular piece, we've worked with Tenasia, who basically evaluated the solution and resulted in an estimate of driving nearly 100x in time that it takes to recover. And what they have done was basically test how long it takes to recover with SteelFusion from a site going down, and assuming that traditional protection would take about 24 hours for recovery. Now, the actual numbers don't really matter because, of course, everyone's environment is a little different. But you can see in order of magnitude, it's very, very easy here to recover, while usually if you have just replication or you have just backup, in these remote sites, it takes a very long time to get the data out and rebuild the environment, even in a virtualized environment, right? The idea here is that we keep on the data synced all the time and up to date in a centralized location, so you can now do whatever you want with it once a disaster actually occurs. So let's look at kind of the outcome of deploying this solution. So first, from a time to provisioning perspective, you see that now you can basically take a golden image, project out data very, very easily, and then within 15 minutes, basically provision a new branch. This is a combination of using virtualization and the fact that you can remotely project out data that allows you to basically build out a branch within a few minutes very, very easily. The other piece, from an RPO perspective, is instead of having a 24-hour window of RPO or something of that nature, now we basically sync data as much as we can. So if you think about recovery, you basically lose very little data, if any. So one example would be when you operate in very remote locations. Let's say you have you have oil or gas or mining exploration company, okay? And you work off of satellite links. There, the data that you have out there is absolutely critical for the business. But because these satellite links are unreliable, making sure that the data is synced all the time is pretty challenging. What we do, on one hand, is allow you to work locally all the time because you have the data out there. But then when the WAN link is back up, we keep on syncing the data back. So this kind of company would be able to get RPOs of a few minutes only instead of having, taking weeks to send over tapes. Sorry. Finally, from an RTO perspective or recovery time perspective, again, we've shortened from a number of days to just a few minutes. And again, this is a combination of using centralized data and virtualization. We just need the data in order to recover virtual machines, and the ability to project out data is what really helps us in order to do so either immediately in the data center or project out to another branch that has SteelFusion very, very easily. So in general, you can see that if you take SteelHead, for example, that has different flavors, one of which is designed specifically for replication, you can really optimize both the delivery of applications from the data center, those that actually reside either on Amazon or centrally located in your data center, and massively optimize the replication across sites. SteelHead DX, which is designed specifically for replication, massively dedupes and reduces the amount of bandwidth needed in order to replicate across data centers. And when you think about it, it makes a lot of sense. When I talked about deduplication and the repetitive nature of data, this is very, very true for replication across sites. We have, between days, very little data that changes, so we can really dedupe significantly. And even brand new data that you'd consider new because we provisioned new VMs, for example, if you break it down into bytes, it's actually very repetitive as well, right? A new VM, new Windows instance, those are all blocks that have been used in other virtual machines, in other services. So the level of dedupe that you can get is very, very high, probably 98, 99% many times. And so a lot of customers use that in order to optimize the DR practices across sites. Then if you like with SteelFusion, you can basically achieve a strong impact, a very massive impact in terms of operationalizing these remote locations because you eliminate data protection and replications from these sites, basically centralizing all the data. And doing so effectively allows you to recover within minutes or avoid disaster when you decide to preemptively move services across sites. All right, so that's all I wanted to cover with you guys. I'm very happy to take questions if you have any. Yes?
The edge device, does that have to be a SteelHead appliance, or does that actually be run on a separate piece of hardware that is virtualization and you run a virtualized version of SteelHead?
Okay. So the question is whether SteelHead has to be a physical appliance out in the branch. So two things. First, if you decide to deploy SteelFusion, it includes SteelHead in it. Okay? And if you decide to deploy just SteelHead out there, so it's basically just to optimize traffic across sites for centralized applications, then it can be either physical or a virtual appliance. Yeah.
How many space we have locally in the appliance itself?
What's that?
How many space we have locally on the appliance?
So the question is about capacity, but is it the bandwidth, the SteelHead optimization across sites? How much from a networking perspective, or to run workloads for SteelFusion? What's that? On the appliance. Okay, so the question is about SteelFusion appliance and how much you can run locally. So this is a physical appliance out in the edge, and we provide different levels of both data storage capacity and amount of memory associated with VSP, the ability to run multiple virtual workloads. And it varies widely. Now, it can be between gigs of storage and a number, dozens of megabytes of VSP memory. So it basically can run a number of workloads. And in terms of storage capacity, remember, it's a couple of terabytes, but it's basically just for that subset of the data, basically that kind of caching mechanism, not for the entire data set. It feels like you have a couple more questions, but I'm not sure. All right, so thank you very much for coming, and I'll stay here for a few more minutes if you have questions.